Alright, so what we have here is we've got 20 mils of acid, and that's the concentration of 0.115, and we've got some sodium hydroxide, and we've got 30 mils of that, and 0.2 molar solution. The temperature is gone up to 25.1, and it started at 24. Alright, so let's actually write the reaction to start off with here. So we've got hydrochloric acid plus sodium hydroxide, and that gives me water plus sodium chloride. Now, let's check that it's balanced, because with these we actually need to have molar, we need moles there with the delta H value. Alright, so we're looking at this neutralization. So let's summarize our information. So the volume is actually equal to 20 mils. So let's chuck that into liters. The concentration was 0.15. Volume here was equal to 30 mils. And the concentration was 0.200. Alright, so the moles is equal to the volume times by the concentration. So if you times these two together, the moles is equal to 0.020 times 0.150. Moles is equal to 0.003. Now if I do that with the sodium hydroxide now, the moles is going to be equal to 0.03 times by 0.200. Moles is equal to 0.006. Now, this, because it's actually reacting as a 1-to-1 ratio, I do not have enough acid to neutralize the sodium hydroxide. So this hydrochloric acid is now the limiting reagent. Now, the change in temperature, so delta T, is equal to 25.1, take the 24 degrees that it started off with. So that means it's gone up by 1.1 degrees Celsius. So we know that if it's gone up, then this is going to be an exothermic reaction, and delta H is going to be negative. Alright, now the mass of water that's involved in this reaction is actually the 30 mils plus the 20 mils. So we actually have to get 50 mils of water increased by 1.1 degree. Alright, so how much energy is actually released? So Q is the energy, mass times by the change in temperature times by the specific heat capacity of water. So that's going to equal 50 times 1.1 times by 4.18. Remember, that is a constant because that's fixed for water. So the amount of energy released is actually equal to 229.9 joules. Now delta H, the molar enthalpy, is the amount of energy per unit mole. So we've got this, so that's the Q divided by the moles, which is equal to 229.9 divided by the limiting reagent, which was hydrochloric acid, so 0.003 moles, and that gives me 76,633.3 joules. Now, this can also be written as 76.6 kilojoules. All right, and that one here, we've actually got 3 significant figures, because if you look back in the question, we've got 3 sig figures here, we've got 4 sig figures there, so therefore we've also got 3 sig figures So you only can be as precise as your least value. So the final answer should only have 3 sig figures. And that's it.